Welcome to America's most advanced fighter jet manufacturing facility, where cutting-edge technology meets precision engineering in extraordinary ways.
Alignment on section 7. Looks good from here, proceeding with the weld.
Security is paramount here. Every person entering undergoes rigorous clearance checks, protecting classified...
If we reroute the plasma conduits here, we increase the energy efficiency by nearly 12%.
Raw materials arrive daily. Aerospace-grade titanium, advanced carbon composites, and specialized alloys.
Computer-controlled cutting machines slice through solid titanium with micron-level precision, creating components that must withstand incredible stress during...
Robotic weldings join fuselage sections together with perfect consistency, creating airtight seals capable of withstanding...
Despite automation, skilled tech finish critical components, applying decades
Make sure the edges are flush against the tool. Copy that, rolling now.
Composite components cure inside massive autoclaves under extreme heat and pressure, transforming raw materials into aerospace takes shape as structural components connect together, forming the backbone that will support engines, weapons, and advanced avionics systems.
Precision rivets secure panels and components together, each one installed according to strict specifications, ensuring structural integrity throughout aircraft. Each powerful jet engine arrives separately, a masterpiece of engineering containing thousands of precision parts.
Engine installation requires absolute precision. Robotic systems position the massive power plant perfectly.
Systems are installed throughout the aircraft, controlling flight surfaces and landing gear through pressurized fluid channels and precision servo mechanisms.
Electrical wiring harnesses snake through the airframe, connecting hundreds of systems. Each wire is...
The cockpit becomes the pilot's command center, where advanced displays, controls, and life support systems integrate.
Every electronic system undergoes rigorous testing before flight.
Landing gear installation demands perfect precision. These components must support the aircraft's entire weight during landing, while retracting seamlessly during flight. Weapons bays are precisely engineered to carry advanced missiles and bombs, while maintaining the aircraft's radar-evading stealth profile during systems integrate throughout wings and fuselage, holding thousands of gallons while maintaining perfect balance and feeding engines efficiently throughout flight. Paint application occurs in environmentally controlled chambers, where temperature, humidity, and particle levels are monitored continuously for perfect results.
The connection point. Maintain current vector.
Steady, steady. We have a perfect fit.
All green. Sequence complete.
The aircraft stands complete, a testament to engineering excellence. But construction is only half the story. Inspectors examine every inch of the aircraft using advanced scanning technology, detecting imperfections invisible to human eyes before flight certification. Destructive testing uses X-rays and ultrasound to examine internal structures, ensuring no hidden flaws exist that could compromise safety during operations. Systems undergo thousands of tests. Every line of code controlling flight operations is verified through simulation before actual flight occurs.
Abort! Execute immediate shutdown sequence. Strip the fuel line now.
Hydraulic systems endure pressure testing far beyond operational requirements, ensuring absolute reliability.
Environmental chambers simulate extreme conditions, from Arctic to local dolly.
Fuel system integrity testing ensures zero leaks exist. Even microscopic fuel seepage could create...
undergoes thousands of extension and retraction cycles, proving reliability under repeated use that simulates decades of operational service.
Integration testing verifies that missiles, bombs, and ammunition load properly, release cleanly, and communicate correctly with aircraft targeting systems.
After months of indoor testing, the aircraft emerges into daylight for the first time, ready to begin the critical flight testing phase.
Crews perform meticulous pre-flight inspections, checking hundreds of items before authorizing the test pilot to attempt the aircraft's maiden flight.
Pilot approaches, representing years of training and experience. Their skill will validate months of engineering work during this critical moment.
Aboard, the pilot begins final checks.
Every switch, display, and control must respond perfectly before engine start approval is granted.
Inside the cockpit, advanced displays come alive. The pilot coordinates with control tower, receiving clearance for engine start and taxi procedures.
Start sequence begins. The turbine spins up, generating tremendous power. Ground crew monitors carefully for any abnormalities during this
to
phase.
the runway, every system is monitored remotely. Engineers in control rooms watch telemetry data streaming from hundreds of sensors.
Mission control monitors everything. Engine performance, structural stress, hydraulic pressure, electrical systems.
The moment arrives. Full throttle applied. Afterburners ignite. Decades of engineering, months of tremendous. Within seconds the aircraft reaches takeoff speed. The pilot smoothly lifts the nose, and the aircraft becomes airborne.
Successful. The aircraft climbs smoothly, responding perfectly to controls. Years of dedication have created another guardian of American airspace.
On the ground, teams celebrate. This aircraft represents American innovation.